We're now going to explore finding distance on the coordinate plane. And this is a skill that you do need to learn, do need to get comfortable with, because it comes up every so often. We never completely get away from it. Finding distance on the coordinate plane. So what we're talking about, if we look at this little coordinate plane on the right of this diagram over here, we see that we got a line segment with two endpoints. One of those is P, endpoint P, and endpoint Q. And in this case, we're being signaled that we have a coordinate or an ordered pair. For P is what's just identified right now as X1 and Y1, and the ordered pair for Q is X2 and Y2. And if we know the coordinates, or that ordered pair, those X and Y values for the endpoint P and the endpoint Q, we can find the distance between those two endpoints. Now, and we have a formula. And that formula is right here. If we're trying to find the distance of PQ, that segment with those endpoints, then our formula is the square root of X2, let's say X2 minus X1 squared plus Y2 minus Y1 squared, and the square root of all of that. So let's move over here to the next slide and let's do one of these. Hopefully I can write this without it being too sloppy. It's a little bit hard to write on this one. This is upright like it is, but we shall see. All right, so here we've got the ordered pair for endpoint E and endpoint F. And in fact, if I wanted to, I could even draw a little thing right here. Here, if I want to visualize this, I'm going to label this as E, this is F, and we're going to try to find the distance between E and F. Well, we're going to take the square root of X2, that's number 2, that's the second one I see, 8 minus negative 5 squared plus Y2, negative 4 minus 6 squared. And we're going to be looking at taking the square root of all of that. Now, this negative right here with this negative 8 minus negative 5, well, that becomes a plus. And so now we're going to have the square root of 13, 8 plus 5 is 13, 13 squared plus negative 5, negative 6, well, that's negative 10 squared, and we're eventually going to take the square root of all of that. Well, let's see, 13 squared, and you can check this on your calculator, but 13 squared is 169. 13 times 13. And negative 10 squared is 100. And now we're looking at taking the square root of 169. Let me make a better 6 there. 169 plus 100, and I add those two together. And now we're looking at the square root of 269. Now I haven't been asked to find an exact value. If it was, I might just leave it in that form. But I've got the square root of 269. And so perhaps I want to think, can I simplify that? And I want to just take just a moment to kind of run through that part of it. And so what I want to do is take prime numbers. I want to try to test out some prime numbers squared and see if those are divisible into 269. Well, let's see. 2 squared. 2 is a prime number. 2 squared is 4. Well, I know 269 can't be divisible by 4 because it's not an even number. It's an odd number. And any number that's going to be divisible by 4 is going to be an even number. Now, not every even number is divisible by 4, but if it's divisible by 4, it's going to be an even number. Let's see, 3 squared. Well, 3 squared is 9. If I try to divide 9 into there, well, I know that 270 would be divisible by 9, but not 269, so I can scrap that. Let's see. Next prime number is 5. 5 squared is 25. Well, it's not going to be divisible. And 25 is not going to be divisible into 269. 275 would be. 250 would be, but not 269. My next prime number is 7. That's 7 squared is 49. Oh, let's see, 49. Well, that's almost 50. So that's not going to be divisible by 50 times 50. That's not going to work. 250 it might be. 300 might be, but not 269. Next prime number is 11. 11 squared is 121. Well, 121 times 2 would be 242, but that's not going to get me to 269. And 13 squared, I know, is 169 because we just did it right there a moment ago. 15 squared, that's not even a prime number. And 17 squared, I'm not sure off the top of my head what it is, but it's not going to be 269. So the answer then is the square root of 269, and then if I were to just determine what is approximately that value, let's see, I'm going to put that in my calculator. We're going to take the square root of 269, and that's equal to approximately 16.4 units. All right, well, let's do one more. See if we'll try to be a little more quick about it, this next one. All right, here I've got two ordered pair, J and K. I'm trying to find the distance between J and K as it exists on the coordinate plane. And J is, we're going to say this is our x14, y13. K gives us our y2s, our x2s and our y2s of -3 and -7. So now again, we're going to take the square root of x2, -3, minus 4, squared, plus my y2 is -7, minus my y1 of 3, so it's going to be -3 then, minus 3, squared. I'm going to take the square root of that. And let's see, -3, -4, that's going to be -7 squared, plus -7, -3 again is -10 squared. And -7 squared, -7 times -7 is 49. And -10 squared, -10 times -10 is 100. And so now we got the square root of 49 plus 100. We add those together, we got the square root of 249. And we kind of went through where we were trying to simplify a moment ago. And we know that we didn't come up with anything 249. So I'm just going to take the square root of 249 and Shazam. No, I'm sorry, it's not 249, that's 149. What am I doing? 149. 12 squared is 144. So no, that's not it. Square root of 149. It's going to be a little over 12. So it is, the distance here then is approximately 12.2 units. Whatever my unit of measurement is, and in this case I do not know. All right, now next up we're going to take a look at finding the midpoint of a segment. So we looked at finding the distance on the number line, and now we've looked at finding the distance on the coordinate plane. This finding the distance on the coordinate plane is something you need to get accustomed to because you'll be using it often, as you will, what we're going to do in a moment, finding the midpoint on both the number line and the coordinate plane.